Hello everyone, I hope you're doing well. In this video, we are going to solve problem 54 spiral matrix together. So let's see what the problem wants us to solve. First, we have a two-dimension array, and the array look like a matrix, and we want to visit each element in the matrix in the spiral way. So we want, for example, if this one will be the matrix that we have. We want to visit element first, element second, element third, then this element, this element, this element, this element, this element, this. So we want to browse the matrix like this. So the result after the browsing the matrix will be the one-dimension array like this. So how we want to solve this problem? Let's see what we have here. Most of the time when we are working on this matrix problem, most of the time, not always, we needed two pointer, that one pointer move vertically, the other one need to move horizontally. So I define two pointer here, and I will use these pointers a lot when solving this problem. What else we can see here? If you see, we are not browsing first row, then second row, then third row. We are going in different direction. For example, when we are checking the elements on the first row, we go right. Then when we reach the last element in the first row, then we go down. Then when we reach the last element in the last column, then we go left. Then we go up. Then we go right again. So I need to have something like a direction to be able to know which direction I'm going to right now. So because I want to implement this one in Java, I defined the enum with the name direction. And as I show you, we are going to solve this problem in a spiral. So we have four directions: right, left, up, down. So we have four directions here. What else do we need? Let me draw a little bigger matrix to make it more clear. Think that we have a matrix like this. And if this one be the x, start from 0, 1, 2, 3, 4, 5. And this one be y, 0, 1, 2, 3, 4, 5. I'm going to start from this element. This one is 0, 0. Then move to 1, 0. Then move to 2, 0. Because the y is 0 is still 0. Oh, sorry, I made one mistake here. First is row, the second is column. So row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4, row 0, column 5. I move like this. And when I get to the last column, I need to change the direction to the down. Then I keep the column and start changing the rows. This one will be row 1, column 5, row 2, column 5, row 3, column 5, row 4, column 5, row 6, column 5. So at the first, we go to, we went to the direction right. Then we go to the direction down. And if you see here, when we go to the direction right, this one, the row be 0. Only the columns was changed. Then when we go down, the column is 5. The row number was changed. But when I'm returning back to the left, what's happened here? The column will be changed. The row will not be changed. For example, when I'm checking this one will be the column 5, sorry, row 5, column 4. Row 4, row 5, column 3. Row 5, column 2. Row 5, column 1. Row 5, column 0. When we went left, and then we went up, the same things happen. We will keep the column, we will not change the column, but we will change the rows. So this is the way that we are going to handle. Based on the direction that we are moving, we will change maybe row, or we will only change maybe the column. So our direction and the row and columns, the way that the pointer will be changed, will be too sensitive to the direction that we are going. So let's continue something that we did here. Then we go down, then left, then up. When we get to this element, what's happened? We will not move one row up again, because we have been visit this one. So we will not visit this row again. So I need to have something to know that this row was visited or not, or this column was visited or not. So I need to know at least what is the minimum of the x. For example, when I started, the minimum was 0 for both y and x. But when I get to this element, I should change them. I should not visit this minimum. So when I change the direction, I always should play with minimum y and x. Because when I'm here, when I go right again, when I get to this element, I should not visit this element, because I visit this column once and I browse all elements in this column. So I need to have something like maximum x and maximum y. So at the time that we start browsing each element in this matrix, the maximum y and maximum x equal to the vertical and horizontal, maximum horizontal rows and maximum vertical rows that we have. For example, in this case, it could be 5. Or in this sample that we have, it could be 3, because this array is a 2-dimension 3 times 3. So let's clean the board and start talking about how we want to implement this solution. So we know that we have an array here. Array has a two dimension. So the result will contain all elements that we have in this array. So the result will be the array with the type integer. But the size of this array should be size of all equal to all elements of the array that we have. So if array, so maximum x. Oh, I'm sorry. I'm just creating something like this. That times maximum y. So if this array is a two dimension, 3 times 3, the result array will be one dimension with 9 elements. Is this array be two dimension, 4 times, for example, 3, the result will be the new one array with 12 elements. So, and to get the result, we should have a loop, something like a loop, and that loop at least we process the content of the loop 12 times or 9 times or x multiply y times. So I need to have a sum loop, and that this loop is working until get to the latest item of the element. So if, for example, if this one be m n, maybe I can change this one to m and n too. This one should be less than. And this is the loop that we have. And then we can return the result. So this will be the main body of the method that we are going to implement. So when we go through this loop, we will start from the first item, then go to the second item, then go to the third item. Then we need to go, instead of going right, we need to go down. Then we need to go left, then up. So we should have some statements here to handle this direction change. I'm just removing this one and I start implementing this section. So think like this, that I'm using the blue to be able to easier to distinguish this one with this one. Think that we have a switch, and this switch work with the direction. And based on the direction, we will decide what we need to do. For example, what we need to do when we are going right, what we need to do when we are going left, up, down. So, for example, I started with the case right. When we are going right, what we want to do? So, first thing first, we want to keep the row and increase the columns. So, for example, something that I need to do is just start and make sure that I'm not going to pass the maximum x. So this one works as long as the x is less than maximum x. If x is less than maximum x, we can increase the x. In the other case, we know that, okay, we reached, if x is equal maximum x, so we know that we are in this element. So we need to go down. So we need to change the direction to down. What else we need to do here? When we change the direction, right now we know that we are going to increase the y. So we just increase the y. One more thing that we need to handle here is next time that I'm starting to going right, I should not visit the first row. So I need to decrease the maximum x. So these are the things that I need to do when going to the right. What happened when I'm going down? We need to check the same things. First, we need to make sure that we are not reaching the last item or the item after the last item. So we need to always make sure y is less than maximum y. And if it's be something like this, we are going to, as you see, we are increasing the y. In the other case, what happens if we get to this element? We should change the direction, go to the left. So direction will be left. Then we need to decrease the x because we are going in the other side. And we need to make sure when we will not visit this row again. So we need to decrease maximum y2. So this is the case that for going right. This is the case for going down. We need to check what will be happen if we want to go up. Okay. I think I just want to make sure that I didn't make it. Oh, sorry. I I handled the right, I handled the down. Then the next thing is left because we went left. In this case, when we are going left, we need to decrease the x here. So we need to make sure that x is greater than minimum x. And as long as that x is greater than minimum x, I can decrease the x. And at the same time, when I get to this element, I need to change the direction to go up. And when I go up, I need to start decreasing the y. Yep. And I need to make sure that I will not visit this one again. So minimum x plus plus. So these are for right, down, left. We have one other case that we need to handle, and that's when we go up. When we are going up, we need to make sure that the y will not get to the minimum, and because I was visit this line before, I should not visit this one too. So I need to make sure that the y is always greater than minimum y, this time plus 1. Because at the time that I was started, I visit this line. but at the time that I was started, the minimum was 0. So I need to check when I'm going up, I go up only to this element, and after that, go to the right. Then I can decrease this one. In the other case, I should change the direction. So here, direction will be changed to right. Right, down, left, up, then again, right. And same things happened here because we don't want to visit the same values again. So, and this is the way that we are going to handle the spiral matrix. So let's jump to the code and implement same thing that we discussed here to see what will be the result. Okay, this is the Leetcode environment, and we are going to implement the solution that we discussed. First thing first, we want to return, sorry, I need to first change this one to Java. We want to return one dimension array. So here is the list. So we need to define the list first. So I'm using the list, list of integer, and I name it list, it's equal. I'm going to return the list. This is the first step. So the second step that we are working on this solution is we need to make sure the array that we receive is not empty. So if matrix is null or matrix dot length equal 0 or matrix dot first item dot length equals 0, just return list. So by this code, we check the corner cases and we make sure that the list will not be empty at the time that we start processing it. The other thing that we discuss is that we need two pointer to be able to move from vertically or horizontally. So I need to define some variables here. I need to define x and y to be able to browse the matrix vertically and horizontally. Okay, I need to define minimum x, minimum y, maximum x, maximum y to be able, as I show you, to be able to know, okay, do I need to visit the last column? Do I need to visit the first column? Do I need to visit the first row, the last row, or the row before the first row? And I name them minimum x equals 0 because this is the initial value, and maximum x that I will set it to the first row of the matrix dot length. These two looks good to me too. Then I need to define minimum y, maximum y, and this one will be the length of the matrix. So these are the things that we need to define. But yeah, discuss one more thing, direction. So we need to have a direction here too. But for the direction, I need to define enum for the direction. Okay, private enum, I name it direction, and direction could be up down, left, right. So at the time that we are going to start, first, as you see, we are going to the right. So I need to define another variable, direction, and name it direction, and the direction will be direction dot right. I think we should be fine now. So the other thing that I showed you, that we have a two-dimension array, for example, 3 times 3. So the result will be the 9 elements. So we need to have a loop. And what we need to do in the loop, we need to iterate through each element of the matrix and based on the direction, find the element that we want and put it in the result list. So I will use the while here, and while list dot size less than, so matrix dot length, because matrix has a two dimension, and matrix 0 dot length. And as long as that I haven't visit all items in the matrix, this loop will be continued. So the other thing that we need to define here is, first, I know that I'm going to the direction right, and at the first time that I need to add the first item in the list. So I will add the first item of the matrix in the list. Then we could have a switch case, and then based on the direction we can decide what else we want to do next. So if the direction be right, I'm going to implement the same things that we did on the board. If x is less than maximum x, do something. In the other case, do something else. And if x is less than maximum x, we can increase the x. Then in the other case, we need to change the direction to direction that down, then increase y, oops, then decrease max x. This is the one that we need for right. I need to have one more line here to break the case. I'm going to implement the same things for down. When I'm going down, I need to always make sure the y is less than maximum y, and as long as this one is less than maximum y, I can increase the y. If I reach the last row, I can go left. When I'm going left, I need to decrease the x, because this is the first element that we will be visit at the time that we are adding it to the list here. And I need to make sure the maximum y that we have here will be decreased, and we will not visit this column again. Just make sure, double check to make sure everything is right. Yes, okay, then we need to implement the case that we go to the left, and for the left, we need to make sure this one is greater than minimum x, then we are going to decrease this one. In the other case, we need to go up, decrease y, and then we need the last case, and the last case is when we are going up. When we are going up, we need to make sure the y, and as I show you, we need, this case should be minimum y plus 1, because when we start browsing, we went through the first row and we don't want to visit the first row again. Then direction change to right. Okay, I think we implement everything that we discussed. Just let me do the double check here. X direction down, what increase y, decrease maximum x, then we go down, less than maximum y, increase y, direction left, x minus y minus, then we go left, decrease the x, change the direction to up, decrease the y, increase the minimum, x, up, y, direction right, x, up. Everything looks fine to me. Let's run the application and see what we will get here. Boom, error array list. That's fine. Line 10, line 14, and line 20, and list cannot find the symbol y. Oh, because the previous error. Array index out of index. Great. Like this type of errors. Okay, let's. Oh, I found it. And these are should be -1. Because we always, software engineers always count from the zero. Good. So as you see, the issue was solved. Both matrix, the result will be the way that we browse the matrix in the spiral way. So this is the code that we implemented in this video. I hope you like it. If you like it, I will be appreciated to subscribe and follow my future videos. Have a great day.